Hello everyone, I hope you all are doing great. Now we begin with the part 2, the writing part for the end of term 3 exam. This is for the grade 9 advance. The first question in the writing part is question 16. It is proving triangles congruent by SSS and SAS. I'm sure you know what is SSS and SAS. SSS means all the three sides are equal to each other, congruent to each other. Whereas SAS means there's a side, then there is an included angle, that is the angle in between them, and another side. So SAS. And that's what it means. Now here let's look into the figure. You can see they have told these two sides are equal, okay, and these two are also equal. So can we prove this is congruent with any of this postulate? Yes, if you look carefully, there are vertically opposite angles, right? See, these are vertical angles. They're congruent to each other. So you have S, A, and S. So yes, they are congruent. You can just tell these sides. So now let's see the sample answer. The given congruent pairs are used to prove that these are sides and sides are congruent. And then the fact that GLH is congruent to JLK. Why? Because they are vertical angles. So they are congruent. Therefore, the triangle GHL and JLK are congruent to each other because of SAS congruency postulate. So this is what is used over here. I hope that is clear. Now over here, let's look into this problem. We know these two sides are equal to each other. And what about this QS? This is also equal to each other, right? Because QS is the same side for both these triangles. So yes, that is also congruent. This is congruent. Can we prove this RS and TS to be congruent? Or any angle? See, we do not have any enough information. We have just two sides that are equal. So it might be congruent, but we currently do not have any information that proves its congruency. So you cannot show that the triangle QTS and SRQ are congruent by either postulate, since it's not known whether QT and RS is congruent. So you cannot use SSS, or since none of the angles are known to be congruent, you just can't tell this is congruent to this. There's no information given. So, we cannot tell anything. Now, if segments, see over here, QS and ST were parallel, then over here, you could have, the alternate opposite angles, interior angles and all are there, right? If these were parallel only, now they look parallel, but they have not mentioned it, then we could have told these are congruent to each other, this is congruent, but here there's no enough information. So that's the thing. And over here, what about this one? Okay, when I look at it, I can understand this is SAS. Why? This side, angle, and this AC is a common side, right? SAS postulate. So that is from the given congruent side and the congruent pair of angles, and the fact that AC is the same side which is shared by both the triangles, we can say it's congruency from SAS postulate, congruency postulate. So these both triangles are congruent to each other. And the last problem here, let us look into this. We have one angle, this angle. Do we know whether this angle is same? Yes, that angle is same. Obviously, because there are, if there are two angles equal, then this must be same, because it's 180 minus, say, imagine this is A and B, it'll be A minus B, right? And here also, it'll be the same thing, 180 minus A minus B. So yes, of course, this angle is same, but still, are they congruent? We know that this side, no, we don't have any sides information, to be honest. So we can't tell anything, there's no enough information. See, both triangles must have three pairs of congruent angles for the third angle theorem. Why? Because if two angles are equal, then from the third angles theorem, we know that these are equal. But here the side lengths are not known at all, right? So we cannot tell whether it's congruent or anything. See, now for these postulates, you need to know whether all the three sides are equal or two sides and the included angle is equal. Now, if you're thinking, if all the angles are same, isn't it congruent? No, let me draw something. Imagine this is the same thing in an enlarged image. I will draw the same angles. Are they congruent? No, they are similar. If all the angles are equal, they become similar. Or if any two angles are equal, they are similar. But to have congruency, that means it's the same size, same shape and angle and everything. That is not possible. Okay, so that is about this problem. So that is the end of the question 16. It's a pretty straightforward question. Just remember SSS postulate or SAS congruency postulate. The question 17 is about proving angle relationships. This is one of the easy, simple topic. Here you are being told we need to find the measure of ABC and CBD, but the total angle is given. So from angle addition postulate, when you add them up, they are side by side, it must be equal to the total angle. So if you add 2x plus 5x minus 6, it must be equal to 120 degrees because they told ABD is 120, right? Now add them up. 5 plus 2 is 7x. This to the other side will be 126 because it'll be 120 plus 6. Now divide both the sides by 7. So 7x by 7 and 126 divided by 7. It's more than 15. 7, 15, 16, 17, 18. Yeah, 18 I believe. So it'll be x is equal to 18 degrees. You can just use the calculator, divide it. Or if you know the tables of 7, you will get the answer 18. So we found the x value. Now if we found the x value, can we find what is ABC? Yes, 2 times 18, it's 36 degrees. What about this? 5 times 18 minus 6. So it'll be 180 half is 90. 90 minus 6 will be 84 degrees. So these are the answers. And that's it, 36 and 84 degrees. Pretty straightforward if you just know the simple things. If you add them up, this is the answer. Solve for x and substitute and get the other answers. Similarly, over here they have told us to find, just like the previous one, JKL and LKM, but the total is given. JKM is given. So add them up just like what we did a while ago. Find x value, substitute it, and solve for the required angles. Now look at this problem here. They have told measure of 6, this angle, and 7 is given. But you can see they both are supplementary angles, right? They are linear pair. Basically, when you add them up, it's 180 degrees because they are on the straight line. So we know measure of 6 plus measure of 7 will be equal to 180 degrees. Now it's 2x minus 21 plus 3x minus 34, that is equal to 180 degrees. Now you solve it up. 5x is equal to 180 plus, because this goes to the other side, it adds up. We can add this, it's 55. And this is going to be 235. And 5x, just divide by 5 over here, it'll be 47. So divide both the sides by 5, you will get x is equal to 47 degrees. So now you just substitute it back, and we have to find all the number angles. We will find it in a while, but if you substitute this as 2 times 47 minus 21, you're gonna get measure of 6, and measure of 7 would be 3 times 47 degrees minus 34. So just put this in the calculators, you can find it. It's 1894 minus 21, so it is 73 degrees, this one. Measure of angle 6. Same way you can find the next one, 7. Now what about this measure of angle 8? These are vertical angles, 6 and 8. So if this is 73, this must also be 73 degrees. So it doesn't matter what's the measure of 6, that will be equal to 8 as well. So here we got 47 degrees as x, and then we measured 6 as 73 degrees, and over here 7 as we will get it as 107. Now remember, since they are vertical angles, see, vertical angles, the above one are linear pay. When you add them up, it's linear pay. Since these are vertical angles, they both are equal. So the measures are, for 6 and 8 it's equal 73 degrees, and for 7 it's 107. Over here, another interesting one, they have told us measure of angle 5 and 6 are equal, and this is 90 degrees. So what happens when you add them up? What should you get? So measure of 5 plus measure of 6, this is measure of angle 5, measure of angle 6, must be actually 90 degrees. Or you can do this, 90 degrees plus measure of angle 5, measure of angle 6 must be 180 degrees, isn't it? Now this 90 goes to the other side, you will have measure of angle 5 plus measure of angle 6 as 90 degrees. So this is the thing. You can directly take it as 90, and since these both are equal, what happens? You know, imagine this is x and then this is also x. So half of this, basically it's 45 degrees, but how you solve this, x and x, it'll be 2x is equal to 90. So x value is how much? 45 degrees. Now if this is 45, both are 45 and 45 degrees. That's how we can easily solve it up here directly. So whichever method you use, since it's a simple problem, you don't need to stick to exact solution. You can just look at this. Okay, this is 90. Okay, then these both must be 90. You can just write that out, and then since they're equal, half of 90 is 45 degrees. That's it. So this is the supplementary theorem. And over here again another similar one. 2 and 3 are complementary, they have told. Yes, because they are 90 degrees when you add them up. And they have told over here 1 and 4 are equal, so this and this is equal, and measure of angle 2 is given to be 28 degrees. So how do we find the other things? Now first let's do this, 2 and 3. Measure of angle 2 plus measure of angle 3, since they are complementary, that means it's 90 degrees, and looking over here you can see it's 90 degree right angle. Now we know 2 is 28 plus measure of angle 3, that must be 90 degrees. Take this 28 to the other side, so it will become 90 minus 28 degrees. So that is going to be 60 plus 2, it's 62 degrees. That is the measure of angle 3. And once you know this, you can say, now we found out 2, we found out 3. Look at this, this is what a straight line, supplementary now. This entire, all the angles must be equal to 180 degrees, isn't it? And we know so much is 90 degrees. So when you add this and this, they must be equal to 90. Or if you write it out, angle 1 plus angle 4 plus 2 and 3 is what? 90 degrees directly is equal to 180 degrees. So if you add angle 1 plus angle 4, that must be 90 degrees. And just now we did this, right? So this will be 45 degrees, 45 degrees, because they both are equal. And 2 is 28 degrees and measure of angle 3 is 62 degrees. So that is how we easily solve it up. See, measure of angle 3 is 62, 1 and 4 is 45. And that's the end of this topic. Another simple topic. Look into the figure properly, analyze all the given, and see what is required to find out, substitute, and easily solve them up. Question 18 is similar to the question 16. It's about proving triangles congruent, but here we use ASA and AAS. This is angle side angle and angle angle side congruency postulates. Let us look into these problems. Here they have given you a lot of information and you need to prove they are congruent to each other. They have asked you two-column proof or flow proof. Now, if you see two-column proof is something like this. This is not exactly two-column proof, but this is okay. And this is, say, a flow proof. In the exam, if you're getting confused with which proof, just write a two-column proof. That's fine. Write it like statements. It's okay. The teacher will give you marks. I mean, if you can do this, it's well and good, but generally they'll just ask you prove. They won't ask, they're not specifying exactly how to do this method itself. As long as you have understood the concept, that's more than enough. Now here, let's see. There is BC parallel to EF. Don't think this is equal. This is parallel. If two lines like this, see parallel, that means they're parallel lines. Now here congruence is over here. They are congruent, means they're equal to each other. What is AB? AB is over here and DE. Okay, they both are congruent. So we have one side. Now look here. We don't use SSS or SAS like in the 16th question. Here we are dealing with ASA and AAS. So we are looking for two angles and only one side. So one side is done. Don't worry about any other sides. Now let's look into the angles. They have already given C is congruent to F. We have one more side that we need to prove. It's either this or this. Let's look at it. Now, since they have told these both are parallel, we can easily tell these both are corresponding sides, isn't it? They are corresponding sides. Why? Because these lines are parallel and it's a straight line. It's a transversal, that means it's cutting. Whatever line that cuts two parallel lines, it will have some properties, corresponding angle, alternate interior angles and all that. So here it is corresponding angles, that is B and E. So you have proved it. There is angle, angle and side, so it's congruent to each other. Now here first it's given, all whatever is given you write it out. The reason is given. Usually you can make two columns and write all these statements and the reason for it. In the bracket you can write in the other column. And then what next? We know that A, B, C and D, E, F must be equal to each other. Why? Because they're corresponding angles. And from AAS, angle, angle, side postulate, we can prove these both are congruent. Now the next one, similar to this, but here we have been told that TR bisects STU. Now this is a bisecting line. What happens is the angles are equal here. And then angle S is congruent to U, this and this. So they both are congruent to each other. Now we need to find one more side that is equal to each other. Now this is given. This is not given. These angles are not given. They have told it bisects. Because it bisects, we can tell these angles are equal because that's the definition of a bisector. And what was given over here? S and U is given. Now we need one more side. Two angles are done. One more side that is equal, right? Look at this side, RT. It is the common side for both these triangles. That means they both are equal. So that is reflexive property. RT is equal to RT. Now, basically you solve it up. From what? It is angle, angle, side postulate. And that's why they both are congruent. Similarly, please do these problems as well. You need to write it in detail, but I'll just tell you how we can analyze this. First given, let's see JK and MK. They are equal, that's given over here in the figure itself. Angle N, angle L. So it's either ASA or AAS. So you need only one side. One side is done. Okay, this sides are done. Angle, one angle is done. Now one more angle is required. Which is the angle I can think of? I can think of this. Vertical angle, right? Vertical angles, they are equal to each other. So whenever you have two lines, these opposite angles are equal and these two are equal to each other as well. So this is it. Now you just need to write it in paragraphs. Over here, since they have asked flow proof, over here this is written. You can see it is given, vertical angles, they're congruent to each other, and AAS. Why? Because angle, angle and side. And here as well, it's a parallelogram and we have one angle equal to another. There is parallel lines. This is given. Now, if they are parallel lines, there are lots of angles equal. Say this angle is equal to this. Why? Because they are alternate interior angles. And look at this DF. That is the common side for both. So that is also equal. So we have angle, angle, side, again AAS. So very straightforward problems. Please analyze the figure. See what are equal, what is parallel, find the required angle, angle and sides. And that's it. Then you can just write in detail. So here V is the midpoint. So midpoint means what happens is any line, midpoint to what? YW. Okay, it's only midpoint to YW. That's clearly mentioned. Now this is the point. If this is the midpoint V, then these lines are equal to each other. So side is done. We need two more angles. They have told these both are parallel. So what happens is these are alternate angles. They're congruent, and this is also alternate angles. They're congruent. So angle, side. Very simple. So there are two alternate angles. You can see alternate interior angles and alternate interior angle theorem over here, both the places. And midpoint means it'll cut the line into half, equal parts, equal to halves. So that's why we have AAS postulate. This is the last problem, and it's just like just now, because over here they have told they are parallel. If they are parallel, alternate angles. See over here, since they mentioned they are parallel, you can tell these both are equal, these both are equal, these are also equal. Why? Because they are vertical angles. And they have told even this line is equal, so they must be congruent. So here lots of information is given, then vertical angles are there, one angle, and one set you can write alternate angle, or you can write over here two alternate angle. That is also fine. That will be angle, side, angle. But if you write like this, angle, and then side, it will be AAS postulate. Let me just make that clear. If I tell here this angle is alternate interior angle, this is also alternate interior angle, and this is given, so this will be ASA postulate. But here in this solution set, they have mentioned one of this angle, and they have asked what they have told about the vertical angle, vertical opposite angles, right? So what happens is, imagine this is not there. It'll be angle, and then angle, and then side, or angle, side. So therefore we write AS. You can prove it in more than one ways. It's up to you. So over here, this is not the only solution. You can write even other way around. And that is it. That's the end of the question 18. If you have any questions, please do post them in the comments. Make sure you write the sentence properly, and it's more preferable if you make these two columns, statement and reason, and then easily write it out. We move on to the 19th question. It is about rotations. Before we begin this question, let us look into some of the formulas which will make these problems very easy. So these are all counterclockwise. Now, if you have realized, how do we measure an angle in the protractor? We usually use this direction, right? So if it's 90 degrees, we don't go clockwise, we go counterclockwise. So it'll be, this is 90 degree from year to year, right? So all these are about the origin counterclockwise, okay? So 90 degree. Now, these are very important formulas. Now imagine you have 4, 3 as the coordinates, x and y, and you're rotating this point about 90 degrees. What happens is, from the origin, okay? Now over here, so there is a point over here. From the origin, you're rotating 90 degrees. Then all you need to swap is, if it's 90 degree counterclockwise like this, right? This point will be somewhere over here, isn't it? Now this is 4, 3. It's not exactly 4, 3, but just imagine it's 4, 3. So it is going to be, sorry, not x, it is minus y. First will be minus y comma x. That means whatever the y over here will come over here and become minus, and the x over here. So is it here? Yes, it's minus 3. If this is 4, around minus 3, and the value will be 4. Yes, around that point. That's how we can get it. Now say for example I have 5, 6 and I want to rotate it along 270 degrees. Then it's gonna be, this 6 is gonna be over here, but 5 will be negative 5. So this is how we solve it. Now if you know these formulas, it's very easy. Remember, for 90 degrees you swap x and y. See, y becomes x, x becomes y. Even for 270. And for 90, first y is negative over here, second, that is x is negative. Whereas 180 is so simple, you just put minus signs both the sides. What about 360 degrees? Now I have a line like this. I want to rotate it 360 degrees. It will be the original position itself, right? It will not change. So that will be the original itself. So let's look into this problem now. Here they have told 270 degrees clockwise. This is the first thing that you need to see. Then we will solve the others. So we cannot use clockwise. We have to do counterclockwise. We will do it in a while. But first, the coordinate of a point. Let's just draw a simple graph. Let me draw it straight. Okay, is 4, 7. This is 4. and minus 7 somewhere over here. Let me take this as the point Q. It's mentioned. And now you're not rotating it about the origin. But the formulas which you know is all about the origin. But here it is at phi and 1. So imagine this is 1. So about this point we are rotating. And we need to find the coordinate after it's rotated 270 degrees clockwise. Now one thing, let me just sort this out. 270-degree clockwise means from here it's coming till over here, right? What is it counterclockwise? It's 90 degrees. So just subtract it by 360, you get the answer. So this is same as 90-degree counterclockwise. So what we do is we use the formula of 90 degrees, which we just now saw. So that is x comma y becomes, it'll be y, but first is negative comma x. So this is the answer. Now, here before we start, the step 1 is rectifying this given point towards the origin. What I mean is, see, this is about this point phi and 1, right? Let's get back to the origin. How much far away is it from the origin? Minus 1 and minus phi, isn't it? So what we do is, to the given point Q, we add this minus 1 and minus phi. The x-axis first. X is minus phi and y is minus 1. But in simple way to remember, look at the given point where it's rotated. Just change the signs of this point. If it was, say, phi and minus 1, it would be minus phi plus 1. But now both are positive, so both will be negative. And add it to this point. From 4 to minus 7, it becomes 4 minus phi and minus 7 minus 1. This is the point. Now the point Q is equal to minus 1 and minus 8. This is after rearranging to origin. Now from the origin we can rotate it along 90-degree counterclockwise. Step 2, rotation. Now here the formula is xy, that is tends, the formula will be minus y comma x. So we have x minus 1, y as minus 8. Now what happens over here is this minus 8, right, will become positive 8. And over here this minus 1 becomes just minus 1. It will be minus 1. Step 3, this is not the final answer. We have done the rotation 90-degree clockwise, but it's about the origin, not about this point. So let's get back to the point. To get back to the point, it's plus phi, and back again it's plus 1, isn't it? So now we add the original point again back to this. So here it is now rotated. Whenever it's dilated or rotated or transformed, we put a dash, that is a prime, q prime. So q prime is equivalent to 8 plus phi comma minus 1 plus 1. This is the thing. So what is q dash or q prime? It's 8 plus phi is 13 comma 0. Why? Because minus 1 plus 1 is 0. So this is the point after 270-degree clockwise rotation. Now let's look at this. Here is the original point, right? When you do 90-degree, it will come somewhere over here. Then another 180-degree over here, 270 somewhere over here. Okay, it will be up over here. Now 13 and 0. So over here, 13, x is 13 and y is 0. It's basically, yeah. Now I'm not doing it exactly, right? Really, you have to measure this distance and then rotate it. Oh, sorry. It's not about the center over here, about this point, right? So now look, this is the center. From here, it will be over here, here, and then over here. Yes, that makes complete sense. It would rotate. But since we have found it technically, like from the formulas, that is the actual rotation point. Or if you want, you can try using protractor and rulers as well, but it'll take a long time to do that. So this is how we solve these problems. Here the step 1 would be, getting the point transformed to the center. That was basically subtracting phi and subtracting minus 1, subtracting 1. Then what we do is we rearrange this towards 90 degrees, not 270. We have to use the formula of 90-degree counterclockwise. That is minus y comma x. And then what we do is we add this back so that it is about this point, not about the origin. So it was 13 and 0. Yes, that is what we got. Similarly, over here as well, you can do it. I'll directly do it now, but you please do it in proper steps and methods. So now, what they have told is JKLM is a parallelogram. The vertices are given over here. What are the coordinate of the image K if the parallelogram is rotated 270-degree counterclockwise? Okay, directly to use the formula XY, this will be it will be y comma minus x now. For 90-degree, first is negative. For 270, second one is negative. About this particular point. So how we start is, we have to just look into the point K. 7. So over here, 7, but you need to add this. This time it's adding because the sign opposite to whatever is given. Comma 1 plus 1. So this is the transform point towards origin. It will be 9 comma 2. And now you use this formula. This is step 1. Step 2 will be swapping this. It will be 2 comma minus 9. And now add this back again. But now this time it will be minus and minus 1, minus 2 and minus 1. So it will be 2 minus 2 and it will be minus 9 minus 1. It will be 0 comma minus 10. So this must be the final answer. So this is how we solve them up. We can see 0 and minus 10. So please do solve all these problems by yourselves. And now here, if you have to do it in do it using protractor and ruler. See, such problems are never generally asked in the exams. Since a long time these are never come. But anyways, just to know, if you have to rotate, say this particular point K, this diagram along this point K by 45 degrees. So what you do is, from each of these vertices, you draw a line segment towards K. Okay, that's the first thing. Now we'll start with one point. And then you see, keep the protractor over here and measure 45 degrees. Now what happens is, this is the base. Now whatever is that line, imagine the line is like this. You keep the protractor and measure, right? 45 degrees. Same way, now this is the base. This, keep this over here around the center, like this, the protractor. And then you measure like this 45 and get the point. Now whatever is, just mark a 90-degree, 45-degree line, and whatever is this distance, you cut it along there. So just draw a straight line for now. Okay, just extend that line. And next one would be, see what is this distance, right? See, once you got that point, measure this particular distance. If say it is 2 centimeters, draw a 2 centimeter line over here as well. And then we get this transform. G is transformed to G prime. So this is the transform point. Now after this, the same thing is repeated. The same method is repeated for all the other vertices, and you get something like this. You can see the same thing is repeated, and other points are obtained. At 45 degrees only you have to do, and that will be transformed. Now if you're rotating this entire image by 45 degree, it's not 90, it's 45, right? Half of 90. So you can see it will be something, yeah, like this. If you just map them, that'll be the thing. So all these distances will be same. See, now these distances generally, if you measure, they must be equal. So the same concept can be applied to other problems as well. Here they have given you 210 degrees. So same concept, draw straight line, join them, measure 210 degrees with protractor, and then use a ruler and solve it up. Now whatever we have mentioned is generally always counterclockwise. So about T, it'll be counterclockwise, and here you get the figure. If you take it 210 degree counterclockwise like this from down. And now we have another similar problem which we did a while ago. XY with endpoints is given. There are 2 points over here. This is rotated 90 degree counterclockwise about minus 6,4. See, such problems will come. Generally, where you have to use the starting problems, right? 2 problems. Where you use the formula, where you have to analyze these points. These are most likely to come. Now you need to transform both the points. So about this point, right? You can draw the figure and stuff, but it's very straightforward if you understand the concept once. 90 degree clockwise formula is xy, that tends to minus y comma x. That's the formula. I will start with the point x over here. It's 3. Now we have to change the sign plus 6, and what about the next one? It will be minus 4. So the value is 9 minus 3. Now rotate it along around 90-degree clockwise. Over here is the formula. It will be positive 3 and 9. And now add them back, the original points where it is rotated along. So it will be 3 minus 6, comma 9 minus 4 plus 4 over here. So it will be negative 3 and we will have 13. So this is the first point x, and the same thing you need to do it for y. Over here it will be 2 plus 6 and minus 2 minus 4, and then we have 8 and minus 6. And what happens is, now swap it up. It will be plus 6 and 8, and now add them back. It will be 6 minus 6 and 8 plus 4. So here you will get 0, and over here we will have 12. So that is the answer, 0 and 12, and the x point was minus 13 and 6. You can see over here minus 13, minus 3 and 13, 0 and 12. And here they have told a damaged compass points northwest instead of north. If you travel west by the compass, what is your angle of rotation to the true north? Angle of rotation, it's 40. Let's just look at the answer and understand. So it's 45 degrees. So rotating clockwise. Now here, this is the broken compass, right? You are basically, say, from west, from this compass west, it will be, this is the true north for the broken compass. It will be 45 degrees. That's what I understand. So it's 45 degrees from year to year, or 315 clockwise. That means if you're going like this, just do 360 minus 45. That will be 315 degrees. That will be counterclockwise. But if you're going clockwise, it's direct. So that's the thing. And over here, a circular dial with digits 0 through 9 evenly spaced around its edges, rotated clockwise 36 degrees. How many times would you have to perform this rotation in order to bring the dial back to its original position? See, 0 to 9 evenly placed, 36 degree one time. So how many? It's a circle, right? So one time it's 36, then again it will be 72 degrees and so on. It will take 10 times, right? Because 10 times will give you 360 degrees. So the answer is 10 times. And under a rotation about the origin, the point phi comma minus 1 is mapped to the point a dash, that is 1 comma phi. Okay, this is already transformed. They have told the rotation is done. What is the image of the point b minus 4 comma 6 under this rotation? So now let's just analyze this and this. So a is the original point. After it's transformed, it becomes a dash or a prime. It is phi and minus 1. And what is it over here? After rotation, it's 1 comma phi. Let's see the relationship between them. Here I can see x became y. So x and y. This, what happened is here, this x is over here, and y became minus y. So how much is this? This formula is for 90 degrees, right? So it is a 90-degree rotation. And now what you can do over here is, instead of 4 comma 6, because it's from origin, you don't have any other point. Directly use the formula. X comma y tends to minus y comma x, that is for 90 degrees, and it will be minus 6 comma 4. That is the answer. Oh, sorry, minus 4. That will be the answer. You can see it's minus 6 and minus 4. That's the end of this topic. Just please be thorough with the formulas and remember the steps. So there are 3 steps. Please be thorough with it. Write and study these problems, and then it'll be easy for you guys. The question 20 is about congruent triangles. Congruent triangles means equal triangles. We have real world problems here. Camila is designing a new image for a cell phone case. If the measure of ABC, let's see, where is ABC? This one is given as 35 degrees, and BAC is given as 29 degrees. And ACB, this measure, is equal to DEB, this one. They both are equal. We need to find DEB. So we don't know the, you can tell these are vertical angles and this is 35, but we don't know this particular angle. So instead of trying with this, the best way is we can easily find ACB and then tell ACB value is equal to DEB. But Looking at this, you can tell this is congruent. Now, this is just for more information, Look at this. They are vertically opposite, right? If this is 35, whenever you have like this across, this and this are always equal. The other side, they'll be equal to each other as well. So now we can say 35 over here, it means this is also 35. Now they have already told this and this is equal. So the third angle, from the third angle property, they must be equal. This must be 29 itself. Okay. But anyways, now we will just consider ACB. From triangle ACB, we know that angle, let's do one by one, ABC plus angle BCA plus angle CAB. What is this equal to? When you add up all the angles of triangles, they are equal to 180 degree, because the sum of all the angles in a triangle is 180 degrees. Now then, substitute. What do we know? We know ABC is 35 and BAC, this one is 29. We don't know this, that is BCA and ABC is the same thing. ACB, sorry. So this is what is not known, but this is equal to 180 degrees. Now take everything to the other side and leave ACB here. So it'll be 180 minus 35 minus 29. You can put it in the calculator and get the measure of ACB. So this will be 150, 45, 115, 116 degrees. So that is the answer. Now this is ACB, but we know ACB is equal to DEB. So even DEB must be 116 degrees. So that is how we can easily solve it up. You don't need to write all these details over here. Just if you understand it's enough. This left side is very important to write. Another real world problem, another interesting one. Mr. Lewis is building a rustic dining table. Instead of having 4 legs, the table has set of supports at each end. If PRQ, where is PRQ, this angle, is equal to TVU, this angle, and RPQ is given to be 49 degrees. And we also know this is equal to over here, 90 degrees. So what is the measure of TVU? This one is unknown. Now this one is not a regular table where, generally you will have 4 sets of supports, isn't it? No. This entire thing is a support which is going down, and this one is the entire thing for support. Now then, how do we solve this is, let's focus on the left side triangle, because we can easily find 49, 90, and this can be found out, right? So I'll write in short forms, angle P plus angle Q plus angle R will be equal to 180 degree. Why? Because the triangle total angle is 180 degree. And now only R is unknown. Let's substitute all that we know. P is 49 degrees plus Q is 90 degrees plus R is the unknown value, that is equal to 180. And take this to the other side. It'll be 180 minus 90 degrees minus 49 degrees. So it'll be 90 minus 49. So it's 41 degrees. That's the answer. It's 41. That's the measure of R. That is PRQ, but we do not need that. We need TVU, but they have clearly mentioned they both are equal. So this is equal to TVU as well. Angle V is also 41 degrees. So that must be the answer. That's the answer. Now we have to write 2-column proof. Now 2-column proof we have done in the previous problems. You will have statement and reasons, see, like this. Okay, I just go through the reasons because it's just the same thing. We have to write it, and we need to understand what is equal over here and solve it up. Now we are not doing anything like SAS or AAA, not those postulates. Sorry, there's no AA postulate. You remember SAS, ASA, all those postulates? No, we are just finding they are congruent. Literally all the angles and all the sides must be equal. That's it. Now they have told AB, the line segment, this is the line segment AB, is equal to CB. And also AD is equal to CD. And BAD, that is angle BAD, is equal to BCD. One question, because I remember long back one student had asked me, why do we write BAD or BCD instead of writing angle A, because BAD and angle A is the same thing, right? Why are we writing like this? Yes, you can write angle A, that's correct. In this case, it doesn't matter at all, you can write directly. But what if I want angle B? Now there are two angles, isn't it? This side and that side. Now, which one am I exactly telling you? So this is the thing. If I tell ABD, ABD, then I will understand this is the angle. Whereas if I tell CBD, it will be this angle. So you know, to get a difference of the exact angle, if I tell just B, it will be the entire thing, right? To exactly specify which is which, that's why we write it in the full forms. But for your, if you understand well, if you're just dealing with one triangle, you can write only A, it's fine, okay? And what about BCD? BCD, this is the angle. BD bisects ABC. Can you see? When you bisect, the angles will be cut equally. If this is, say, 50 degrees, it will be 25, 25. Now, this is all given. We need to prove that ABD and CBD are congruent to each other, the triangles. So now we know a lot of information. We know this angle, we know this angle, we know this angle, because bisection means this angle, right? Now, if two angles of a triangle are known, see, now this is equal to this is equal to this. So this must be equal to the other side. Why? Because the other two are known, right? Now, this one, how is it equal is, imagine this is say 40 degrees and this is 50 degrees. Now, we know this is 40 means this is also 40, this will be 50. Now, how do you find the other angle, the one unknown angle of a triangle? It is 180 minus the other two known ones, 40 minus 50. So even over here, it's the same formula. So whatever happens, it'll be 90 degrees, right? 80 minus 40 is 140 minus 50 is 90. So this will be 90. This will also be 90. So that's why if, you know, two are same in a triangle, the third one in both the triangles will be equal. So this is by third angles theorem. You can see that's the third angles theorem. See, lots of things are given over here. Just the given things are written, each angle, everything is given. Now, if something is bisecting, this angle will be equal. That is definition of angle bisector. So all the angles are found out, they are equal. Now, what about this BD line? It's a common line for both, so it's a reflexive property, it's a reflection, right? So because of reflexive property of congruence, that is also equal to each other. So literally all the sides and all the angles are equal, therefore these two triangles are congruent. That's how we can prove it, but we need to write in detail. Same thing over here. All the sides, see, two sides are given. BD is a reflexive property. What about the angles? They have told, you know, the two angles they have clearly mentioned. ABD and CBD is equal. ADB and CDB are equal. So the third angle property theorem says that all the three angles must be equal, and all the three sides, including BD, because of reflexive property, they're all equal. See over here, the detailed answers are given. And even over here, but over here what happens is, see, these two angles are vertical opposite angles, vertical angles. So that's why they are congruent to each other. And then the other angles they have already mentioned, see, A and C are equal, and D and B are also equal. They have clearly mentioned. And about the sides, see, AD is equal to CB, AE is equal to CE, and they have told AC is bisecting the line BD. Whenever there is a line being bisected, means imagine this is a 10 centimeter line, you bisect it, it will clearly be half, 5 centimeter, 5 centimeter, equal parts. So that means this and this is equal. So that is the segment bisector definition. And therefore all the sides and all the angles are equal, therefore the triangles are congruent to each other. That's how easily we can solve these problems, and that's the end of the question 20. The last question in the writing part, the 21st question, it is proving angle relationships. Here we have been given some angles, we have been given a figure, and we need to find, say over here, we need to find what? Measure of 3, angle 3, that is this angle. And they have given us measure of angle 1 is 23 degrees, and we know this measure of angle 2 is 90 degrees, and measure of ABC, the entire thing, is 131 degrees. So how can we solve this? Very simple. So when we add this all up, all the individual angles, A, see this measure of AB and this point, that's measure of 1, 2, and 3, it must be 131, right? Angle 1 plus angle 2 plus angle 3 must be equal to 131 degrees. Now let's substitute what we know. 23 degrees is 1, now 2 is 90 degrees, and lastly we have 3 that is unknown. And that is what we are solving for. And this is 131 degrees. Now take everything to the other side and solve for only 3. So it'll be 131 minus 90 minus 23. So it'll be 41 minus 23. It will be 21 and 18 degrees. So the measure of angle 3 would be 18 degrees. So that's how we solve it. Over here, and there we go, it's 18. And over here we have another similar problem, but they have told 2 and angle 4. See, this and this angle are supplementary, and also 4 and 5 are supplementary. What does supplementary mean? When you add two angles, say when you add 2 plus 4, it must be 180 degrees. And also when you add, that is angle 5 and 4, it must be what? 180 degrees. What does this mean? This means that 2 and 5 are equal. Because over here, see, this is same. Cancel, cancel. These must be equal, right? Otherwise, it won't work out. So this is the thing, and they have told measure of angle 4 is how much? 105. So we have to find each numbered angles. So let's start with the first one. Let's use this relation. Angle 2 plus angle 4 equals 180 degrees. And let's substitute what we know. 2 is unknown, plus 4 is known to be 105, so it's equal to 180 degrees. Take this to the other side, it'll be 2. 180 minus 105, that is 75 degrees. That is the measure of angle 2. If you know that is 75, then this is how much? This is 75 itself. And then we know this is 105. Now if this is 75, this must be again 105 degrees itself. So that is the answers. You don't need to solve it, but you know these both are supplementary, right? 2 and 3 are supplementary. It's a straight line. 2 plus 3 is a linear pair or supplementary. When you add it, it must be 180 degrees. So that is how we solve it. Just remember what is given exactly. What are supplementary? Write it out and then solve it up. So those are the answers. And over here they have told angles in terms of equations. You can see this is 3x plus 12 and this over here is x minus 24. So how can we solve it? When you add them up, they are 180 degree because they're linear pair. It's on straight line, or they're supplementary, isn't it? So you can just do 3x plus 12. First, before that, write measure of angle n plus measure of angle 10 is equal to 180 degrees. So 3x plus 12 plus x minus 24 must be equal to 180 degrees. Now let's solve it up. 3x plus x is 4x over here. 12 minus 24 is negative 12 is equal to 180 degrees. You can solve it in calculator, but since it's writing, you need to do the steps as well. And we'll take this other side. 4x is equal to 180 plus 12, and this will be 192 degrees. That's 4x. And it's 50 minus 2, that is 48x is 48 degrees. So if x is 48 degrees, we can find what is n, 9 and 10. See, now this is not over. We just found out the x value. Now we need to find the measure of angle 9. That is 3 times 48 degrees plus 12. So over here we will have 150 minus 6, that is 144 plus 12, that is equal to 156 degrees. The same way, what is measure of angle 10? Now over here you can do 180 minus this, or let's solve it as x minus 24, that is 48 degrees minus 24 degrees, that's 24 degrees only. So it's 156 for the measure of angle 9 and 24 for the measure of angle 10. So you can see it's 156 and 24, and x value was 48 degrees. And the last problem in the writing part, That is over here given, it's just like what we did a while ago. Here they have given measure of angle 3 and 4, but here they are vertical angles, so they are equal or congruent to each other. So measure of angle 3 is equal to measure of angle 4, and what happens over here is 2x plus 23 will be equal to 5x minus 112. So let's solve it up. Wherever x is higher, which is the coefficient of x having higher value? 5x. Leave it over there. 5x remains over there, and the 2x moves to the other side, it becomes minus 2x, and this negative 112 to the other side. It's most important way to know where is exactly 5x. Leave it, everything else to the other side will be 23 plus 112. Now here you can just solve it up by 112, 30, 22, 32, 35. 135 equals 5 minus 2 is 3x. Now it is divided by 150, 45 is equal to x, and that's the answer. So here, yeah, 45, and now it's still not over. So you need to put this 45 value back in these two equations and solve for it. You can see over here, find the measure of angle 3 and 4. And since they are equal, if you just find the measure of angle one of the measure, it's fine. They both are equal. Directly you can write. Even if you put x in both these conditions, it will be the equal answer. So this is how we solve it out. And that is the end of all the problems in the writing part. I hope you're finding my videos helpful. And I just want to first of all, thank all the students who, share my videos, who like and subscribe to my channel. It means so much to me. It is over 7,000 subscribers, and I'm really, really humbled by your support and love. Thank you very much for that. And I kindly request, if you have not yet subscribed to my channel, please do subscribe. It would mean so much to me. And do share my videos with your friends who might find them helpful. That would be a great help you can do to me. Thank you guys, and I wish you all the best. And please do stay tuned. I will try to do the part 1 as soon as possible. Bye bye for now.